Now I'm going to start answering some past paper. Okay, I will show you. Okay, you are going to see that we can do the first 3, 4, 5 questions from each year approximately. Okay, I choose these two random years. Okay, May, June 2020. Okay, paper 4 time variant 3, and also I choose this year. Okay, the May, June 2019 paper 4 time zone 1. Okay, now let's do the first one, May, June 2019. Okay, let's do the first few questions, 3, 4, 5 questions. Let's see what are the questions and they ask about it. First one. Question number 1. يلا مع بعض. Bismillah. A rocket is stationary. Okay, on what? A launch. Okay, a launch pad. Okay, at t=0, the rocket engine was switched on. Okay, and exist gases as what ejected from the nozzle, okay, of the engine. Okay, the rocket accelerates upwards. These are the information that, as you can see, this is the acceleration time graph. As you can see, the acceleration is increases, okay, uniformly, then becomes what? Constant. So this is increasing acceleration, and this is what? Uniform what? Acceleration. Okay, first of all, what they ask, define acceleration. Who can tell me what's the definition of acceleration? Yeah, 5 words. What's the definition of acceleration? The rate of changing, the rate, yeah, per time, the rate of changing what? The rate of changing velocity. Why velocity? Because velocity, that means it changes speed and change direction. Okay, thank you, Laith. Tamam. So the rate of changing velocity. Now, on this figure, okay, we need to sketch the graph that shows how the speed, okay, varies with the time. Look here to this graph, okay? Now we need to compare between this and this. At this moment here, there's change, okay? Here there was increasing acceleration. That means the acceleration wasn't constant. Then it becomes what? Uniform acceleration. If I want to draw the speed time graph for it, how it will look like? How it will look like? It will be what? Increasing speed with increasing rate. Why increasing speed? Because this acceleration with increasing rate, because the acceleration increases. Then I will continue this by what? By a ruler, okay, to keep the same gradient like this, okay, by ruler like this. So this is supposed to be what? A straight line. Forget my drawing is not straight line, but I'll try to draw it as a straight line, okay, as I can. So this is here curved, okay. Then this curve becomes what? When the time here after a while, okay, it becomes what? Straight line, because it becomes constant acceleration. So the change of the speed remains constant. So curve, that means increasing acceleration, then straight line because it's constant acceleration. 3 marks, and here 1 mark. Okay. Next question. What do they say? Sometime later, the rocket is far from the Earth. Far from the Earth. That means there is no atmosphere. There is no huge gravity. Okay, this is the information they give to us to understand it. Okay, the effect of the Earth gravity on the motion of the rocket is what? Is negligible, huh? They tell us. As the rocket accelerates, its momentum increases. Its momentum increases because they go upwards, okay? And why it goes upwards? There's no other forces active. So, state the principle of conservation of momentum. We said that, okay, for momentum, the total momentum before equal the total momentum after. That's the conservation of momentum, okay? But this is 1 mark. The second mark, okay, in isolated system. What do I mean by isolated system? When there is no resultant force act on it. So the total momentum before is equal, before what? Before the collision, before the expansion, because the explosion, because the motion happens, because of, okay? So the total momentum before is equal to the total momentum after, or the total momentum remains the same, okay? The total momentum remains the same in any insulated what body, huh? Remains the same when there is no resultant force acted. When there is no resultant force acts on a body, on the body. So the total momentum of any body remains what? The same if there is no resultant force acting, or the bodies, okay? Okay, acting on the system, huh? On the system, if we are talking about two bodies, okay? Type. Explain how the principle of conservation of momentum applies when the okay, to accelerate what the rocket by existing gas. Now we know that as the gas is exhausted backwards or downwards, okay, it has lose momentum. This momentum lost by the gas is equal to the momentum gained by whom? By the rocket. So that means there is impulse and force on the rocket that causes what? It to accelerate. The exhausted gases lose momentum, which is equal to the momentum, to make it equal, to make it remains the same, equal to the momentum gained by the rocket, to make it what? And by causing impulse and force on it, by causing impulse and force on it, and this force caused the acceleration. Force on it. تمام؟ حلو؟ هي 8 علامات تذكر 8. Okay, now let's move on. Next. What this is? The figure, this question number 2. The figure shows what? A sign, okay, that extended over what? A road, okay? We have support posts. We have a concrete block here, which is 70 centimeter away from the center of the axis of the support. And we have the point P, okay, 1.3 meter away. And we have the accident slow down, okay, the sign, which has a weight away from the line of action of the weight away from the post by 1.8 watt meter. The mass of the sign is 3.4 times 10 power 3 kilogram. Calculate the weight. We know that weight equal what? M multiplied by G. So what happens here? It will increase by only 1 0. So it will be 10 to the power of 4. And don't forget that it's in Newton. It's not the same. No. The weight is not the same as the mass. The mass, okay, by multiplied by 10 is equal to the weight. Okay, لا تمام. طيب, next, B. The weight of the sign acts, okay, at a horizontal distance of 1.8 from the center of the support, okay, post, and it's provided by turning effect about B. Now, how far is this distance? The line of action of the weight and where the pivot is acted. It's 1.8 minus 1.3, which is 0.5. Okay, point P is on the horizontal distance of this from the center of the support. Calculate the moment. Yes, thank you, no problem, no problem. So moment, okay, caused by the weight is equal to the force, which is the weight, multiplied by the distance, what, of the weight to the pivot. So the force of the weight, which is 3.4 multiplied by 10 to the power of 4, multiply by how far it is, which is 1.8 minus 1.3, 0.5. And by using calculator, it will be 1.7 times 10 to the power of 4 Newton dot what meter. Okay, tamam. Okay, next. Now let me check. We can check the mark scheme here that we get the correct answer. Yes, it's 1.7. Yes, good. Okay, now as we continue here, part double I, the concrete block is what? Is positioned at the other end of the support post with a center of mass to the horizontal at a distance of 70 centimeters from the center of the support. What do we mean by the center of mass? The point where what? The point where, yes, the point where all the weight and the mass concentrate on or acts on, where all the mass concentrate at, okay, or the point where the weight acts on the object, or all the weight acts on the object. Now, the weight of the concrete block produced a moment about P. Now, as we said here, look here to the graph. Okay, to the figure. Let's change the color. Okay, we have this point P, and we have this force downwards from the concrete that causes a moment anti-clockwise, and this force from the weight that causes a moment what? Clockwise. So the moment clockwise that we just find it out, and the moment anti-clockwise by the concrete block, they have to be cancel out each other, or one of them must be greater according to the question that they would tell us. They didn't tell us yet. What they say? The weight of the concrete produce a moment that exactly cancel the moment caused by the weight. Calculate the weight of the block. So moment clockwise, which we just find it out 1.7 times 10 to the power of 4. Okay, equal moment anti-clockwise. Now, what is the moment anti-clockwise? Is the weight of the concrete block that we want to find it out, multiplied by the distance. How far it is? Look here how far it is. It's from P to this line of action, which is 0.7 plus what? 1.3, which is 2. So that means here, this distance, okay, we need to find the weight. Okay, so the weight equal 1.7 times 10 to the power of 4 divided by 0.7 plus 1.3. That means the total is 2. So the answer is 8.5 times 10 to the power of 3 watt in Newton. That's half of 1.2, 1.7 times 10 to the power of 4 in Newton. Okay, good. تمام. Any question? Is it clear? واضح؟ نكمل؟ الأمور تمام؟ Okay, so again, شباب صبايا, moment clockwise equal moment anti-clockwise about the point P. So that's why I take the whole distance, okay? Not from the support, from the point P, okay? We have to be careful. تمام. Next, okay, the concrete block is removed. The sign and the support, okay, post rotate about the fixed point P, okay, in the clockwise direction. State and explain what will happen to the moment about P due to the weight of the sign as it rotated. As it rotated, look here. As it rotated about, okay, the point P, let's assume it starts to rotate, and this is the new position of the post and the sign. Okay, something like this. Now that means the weight, which is the center of the sign, instead of being like this, it will be what? Here. So it will be farther. So as the distance of the weight, the perpendicular distance, get farther, what will happen to its moment? It will increase, get bigger, exactly. So the weight makes a further distance to P, causing greater what? Causing greater moment. Okay, this is what? 10 marks plus 8, 18 marks. Okay, why I count the marks? I want to show you how many marks we are going to answer so far, only from what we study in 9th grade. Okay, next question number what? 3. In question number 3, what they said, a cube of side, okay, 0.04 meter is floating in a container of liquid. So we have a cube of side 0.04 multiplied by 0.4 multiplied by 0.4. They give us the dimensions. This figure shows that the surface of the liquid is 0.028 meter above the level of the bottom of the face. So it's only 0.028 meter sink, okay, and the rest of it float, okay, above it. And we have a pump here to what? With a valve. We have liquid here that the cube, ice cube, float on it, and there is air above it. The pressure of air above the cube exerted by a force on the top surface. Okay, the value of the valve is closed. Explain. Explain in terms of air molecules how the force due to the pressure of air is produced. Now we know that air molecules, they keep what? They keep moving randomly, like this, okay? Why? They keep what? Brownian motion. They keep hitting each other, okay? So as they what? Keep hitting each other and keep hitting the top surface, they hit and bounce, change their momentum. And as they change their momentum, causing impulse and causing a force that spreads out on the what? On the whole area, and this causes what? The pressure. So the air molecules keeps moving randomly and hit the top surface to change and bounce, hit the top surface and bounce, changing their momentum causing impulse and force on the surface, on its area, causing impulse and force on its area, which is the pressure. 3 good marks, right? Okay, continue. The density of the liquid in the container is 1,500 kilogram per cubic meter. Calculate the pressure due to the liquid at the depth of this. So we know that pressure equal density of the liquid multiplied by gravity acceleration multiplied by depth or height. So 1,500 multiplied by 10 multiplied by 0.028, and by using calculator, where's our calculator? 1,500, okay, multiplied by 0.28 multiplied by 10, and the answer is 420 Pascal. Okay, now what they said, the force on the bottom face of the cube caused by the pressure. Now we know that pressure is equal force over area, and they ask about the force, so that means force equal pressure multiplied by what? Multiplied by area. The force caused on the bottom face of the cube caused by the pressure of the liquid only. Okay, so the pressure, which is 420 multiplied by the area. How big is this area? Now we know, they tell us that it's a cube of 0.04 meter side. So we write 0.04 square, okay, because this is the surface area, it's length times width, and since it's a square, Okay, so it's 0.04 square, and the answer is 0.672 watt in Newton. Now next, what they said, the valve is open. Now this valve is open and there's liquid get inside. Okay, the valve is open and the liquid is pumped into the container. The surface of the liquid rises a distance of 0.034 meter. It was a certain depth, it rises. Okay, the cube remains floating with the same, okay, in the liquid with the its bottom this, okay, below the surface as it was. Calculate the work done on the cube by the force. Now we know that work equal force multiplied by distance. Now what is the force? The force is from the lower surface, okay, of the water, okay, that acts upwards on it. So as we can see here, what they said in the mark scheme, okay, here, I'm sorry, here, okay, they said that work equal force multiplied by distance, and the force, which is 0.672 multiplied by what the depth that they give it to us, that how much it rises. Okay, so the answer here, the work that we just find out, the force 0.672 multiplied by how much it rises, 0.34, and the answer by using calculator is 0.023 joules. So just one reason why this is not an efficient method of lifting up the cube. Why this is not an efficient method? Who can tell me? Why this is not a correct way or efficient way? Yes. Why? Look what they said. Lifting liquid as well, because we are not only lifting the cube, also we lift liquid with it. Okay, and there is what friction between the liquid and the container or the pipe. So that means there's a lot of work is done, okay, as a friction due to the friction between the liquid and the pipe as we pump it in. So extra work is done to lift the liquid, and due to friction between the liquid and the pipe. Between the liquid and the pipe. Now, as we remember before, this is another 10 marks, 10 plus 10 plus 8. I'm talking about how much total. It will be 20, what? 26 marks, okay? 26, well, that's good out of 80. But let's continue here. Question number what? Oh, yes. Question number 4 talks about something that we didn't finish it about specific heat capacity, but we can answer, okay, the other parts of it, okay, not all of it, okay, especially this part, okay, which that talks about the P1 V1 equal P2 V2 and what will happen for the piston as well. I will not, okay, I will neglect this question, okay, for now, but I will show you something. If we go back to question number 5, okay, liquid and gases are two states of what? Of matter. We have several states of matter. The main state, three states of matter are solid, liquid, gas. Okay, there is plasma, and there is another 15 different states of matter according to the several theories of physics. Okay, in both boiling and evaporation, okay, the liquid change into what? A gas, from liquid into what? Gas. State two ways in which boiling is different from evaporation. In boiling, there is what? In boiling, there is bubbles. Right? Boiling happens at certain what? Temperature. Boiling happen at certain temperature. These are differences. So we can continue the statement. We can continue saying, in boiling there's bubbles, but evaporation no. No in evaporation. Evaporation. Okay, yes, tamam. Boiling happens at certain temperature, while evaporation at any temperature. While evaporation at any temperature. At any temperature. Okay, next. Before injecting a patient, a doctor whips a small amount of what? Volatile liquid on the what? Patient's skin. Explain in terms of molecules how this procedure cools the patient's skin. Now, why it cools the patient's skin? Because this liquid, it will evaporate. And as it evaporates, it needs energy to break the bonds between it to change from what? Liquid to gas. From where it will gain this energy? From the body of the patient. So that means the body of the patient lose energy, okay, and that's why it cools down. And another thing, the molecules that remains on the inside the liquid, it's only the molecules that have low average kinetic energy. So that means, okay, the molecules that have high kinetic energy, they escape, and the molecules that are cold, they still in. If we go to the mark scheme, we will see that the answers here, what they said. Most energetic molecules escape, okay, from the liquid, or molecules gain energy and escape, okay. Average speed decreases, the average molecules that remains, they have less kinetic energy behind, okay. The temperature of the liquid, what? Decreases. So that means the thermal energy, what? Conduct or they gain from the skin, okay, or thermal energy is lost by the skin from the patient, as we said. So if I want to write the answer here, okay, what I will say, I will use my own words and I'll write that energy is needed to do work against the molecules to break the bonds and leave the surface, or leave the liquid. Okay, so the most energetic molecules, molecules leave and escape, leaving behind molecules with lower energy and lower kinetic energy and temperature, lower kinetic energy and temperature. So heat is gained from the skin of the patient. Heat is gained from the patient skin. Tamam? For good marks and 2 other marks here. Okay. 26, remember. Now, gases can be compressed, but liquid is incompressible. Not all of liquid, but they give us this information. Explain in terms of molecules why liquids are incompressible. The separation distance between the liquids are what? Are close. There is no separation distance as what gases there are far from each other. They are close from each other because of the high bonds. So what that causes? As you can see, molecules, they are touching each other, or there is no space between the molecules. Okay, so there's large repulsion or attraction forces. Okay, when they move closer, when they get close to each other, the molecules, they will repel from each other, or they will interact to each other, move away from each other. So that's why it does not compress. So liquid molecules are close to each other, and by compress them, there is repulsion force between the nucleus and the nucleus. There is repulsion force, move them away. Repulsion force, move them away. Okay, another 8 marks. 26 plus 8, we're talking about 34. In that year, 34 was high C. In that year, 34 out of 80 was high C. Okay, so شو يعني هذا الحكي؟ يعني إذا أنا رجعت للكويشن نمبر 4 اللي قبله وحليت البارت B بس اللي عليك I think 6 marks, I will get B. هذا أنا لسه ما ختمت المادة ولا خلصت حتى نصها، بس أنا صرت أقدر أعرف أحل الأسئلة. هيك بنقدر شايفين امتحان الإيش الماي جون 2019 اللي حليناه هلا كمان بدنا نحل كمان امتحان